thing you try to do. Plug it in. So if I plug in 0, what is cosine of 0? So this is negative 5. Negative 5 times 1 is negative 5. The number 2. Try to plug in b. If I do, I get 0 over 0. But does this factor?
Yes.
The denominator is a difference of perfect squares. Would you agree? X cubed plus b cubed and x cubed minus b cubed. And the x cubed minus b cubed cancels. And so I get b cubed plus b cubed, which is 2b cubed. Oh yes, it would be 1 over 2. Limit as x approaches 0. I get, when I plug in 0, what do I get?
0, 0.
Uh-oh, what does that mean? There's more work to be done, right? There's a whole more work to be done. What are my 2 options? I can either multiply by the conjugate, or I can use L'Hopital's. Either way. Now, I will tell you it's about equal on difficulty level because L'Hopital's does require a chain rule. So it has a little work in the derivative. Although you're more familiar with derivatives right now, the other way you'd have to multiply by conjugates. Which way do you want to see me work it? L'Hopital's. So if you do L'Hopital's, this is the limit as x approaches 0 of 0 minus 1/2 4 minus x to the negative 1/2 times negative 1. Have to do a derivative that involves a chain rule on the top. Everyone see that? The 4 minus x to the 1/2 power. We get 1/2 comes in front. The negative was already sitting there. 4 minus x to the negative 1/2 times negative 1 over 1. Then you can plug in 0. 4 to the negative 1/2 power is 1/2. You have to know that. If you're using L'Hopital's rule, you do it this way. You have to know what that negative exponent means. So I get negative 1/2 times negative 1/2, or sorry, negative 1/2 times positive 1/2 times negative 1, which is a 4. If I did this with conjugates, I would multiply by 2 plus the square root of 4 minus x over 2 plus the square root of 4 minus x. On the top, that would give me 4 minus 4 minus x. On the bottom, I would get x times 2 plus square root of 4 minus x. Any questions so far? The 4's cancel, I get a negative x on top. Those negative x and the x cancel to give me negative 1 on the top. Plug in 0, I get 1/4 again, which I should. Those are the 2 ways to do that. The next one, the limit as x approaches infinity. What do we look at when we look at the limit as x approaches infinity? The powers, right? The highest powers. The limit as x approaches negative infinity. What's the highest powers? The bottom's bigger. What's that mean? So it actually doesn't even matter that it was negative infinity on that one. Limit as x approaches infinity on this one. Right, that would simplify to 3x over 5, right? And if I look at plugging in infinity, I would get infinity. Next one's a tough one. Square root messes with things. What is the square root of x squared? Just x. So at some level, this should be something that has to do with a 3, right? I just need to know.
Teacher, please excuse the interruption. An email has been sent out for me. Would you please read it?
Okay? So I know it's 3. I just need to know if it's positive 3 or negative 3. So if I look, what happens if I put a negative number in the bottom? It's going to be positive. What happens if I put a negative number on the top? So what is this going to be? That one was a little bit tough. Final limit is x approaches 1 on number 8. I'm going to have to look at the limit as x approaches 1 from the left on e to the x. Then I'm going to have to look at the limit as x approaches 1 from the right on x squared e to the x. What did I get when I plugged 1 into e to the x? I got e, right? What do I get if I plug 1 into x squared e to the x? E, right? Since those are the same from the left and the right, what is this limit? The limit is x approaches infinity, e to the x over 1 minus x cubed. Highest powers. You tell me, which one's bigger, e to the x or x cubed? Which one grows faster? E to the x. So this one has a top bigger than the bottom, so it's either infinity or negative infinity. Everyone agree with that? Okay? If you are unsure, plug in some really big numbers, right? E to the 100 over 1 minus 100 cubed, right? What kind of infinity am I going to get? Sine of 3x over sine of 4x. This one actually takes some work. We have well, there's a couple ways. If I plug in 0, I get 2 over 0. L'Hopital's rule. If you didn't want to use L'Hopital's rule, you'd have to use special limits, which would be more difficult. Multiply by x on top and bottom and work from there. The derivative of sine x is cosine of 3x times 3. Cosine of 4x times 4. If I plug in 0 into cosine, I get 1, so I get 3/4. One more. The limit as h approaches 0 of sine of pi over 2 plus h plus sine of pi over 2 all over h. What is that? It's the derivative of sine of pi over 2. Right? Which is cosine of pi over 2. So, quick limit review. That was this helpful to review some things we might have forgotten. Okay?